Broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS, welcome to today's webinar on Shift Left and Friends and what they mean for you. I'm Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we have delivered insight and confidence to hundreds of clients around the world. Our team of international consultants deliver customized training, consulting, and expert services to companies that are looking to improve their test and quality assurance practices. I'm the author of 14 books on software testing, including 6 books on the ISTQB program. Attendance at today's webinar earns PMI PDUs. I would like to thank Rex Price for reviewing the materials for PDU status and making valuable suggestions. Attendees will receive an email telling them how to claim PDUs, including the PDU code. PDUs are available for live webinar attendance only. Excuse me. Before we start the presentation, a couple of housekeeping notes. If you have any questions during the course of the webinar, feel free to submit them throughout the presentation via your webinar interface, but please note they are answered only at the end. There's no need to ask for presentation copies. The presentation is on the web at rbcs-us.com in the basic library. By attending this webinar, you are automatically registered for the free e-learning drawing. Check your email over the next couple days and watch that spam filter. We hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not just for profit company. If you enjoy our free webinars and feel that they demonstrate solid insights into the kind of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. We're happy to provide a quote for any such help you might need. Contact us at info@rbcs-us.com. Okay, so you may be wondering, what is this 2x4 on the front of this slide? What is the point of the 2x4? Now, for those of you outside the United States, 2x4 is 2 inches by 4 inches, a piece of wood used in construction, though it's actually not 2 inches by 4 inches, but it goes by that name. And this is a replica of something, and I wish I had a picture of the original that my colleague, Ren McNary, who was a very skilled, qualified QA manager, QA director, I think was his actual title at Dell Computer when I was doing consulting work there in the 1990s. He carried this thing around because he and I were working on this project, which was had a longer, fancier name, and it was called Shift Left. And the whole point of Shift Left was to shift the defect discovery and removal process closer to the point of origin of the defects themselves. And this was, again, the 1990s. So people running around talking about Shift Left now may think they're really onto something new, but in fact they're just rediscovering best practices that have been around for a long time, which is, of course, the way these things usually go. So there's Shift Left, which again, commonly means things like moving, as I said, the discovery of defects closer to the point of origin. And then there's some other terms that you're probably hearing, buzzwordy kinds of terms like continuous integration and continuous delivery, continuous deployment, DevOps, and so forth. So one of the things I want to do is kind of try to demystify those terms for you a little bit today at the outset, so we know what we're talking about when I say Shift Left and Friends. So these are the friends, and what are they? And then we're going to get into what's an SDET. And are you an SDET, or do you want to be an SDET, which I would say the answer is yes. We'll look at automation, and I'm going to try to convince you that you shouldn't be worried. People tend to sometimes be worried about where things are going, but I'm going to lay out some ideas for you, things that you can consider to put into your career path. And I think don't worry, be happy, as the song goes. There's a lot of really fun and exciting and fascinating stuff that's associated with the whole left shift kind of situation. So get ready for a fun coming period. Let's look now at why I think that's going to be fun and exciting. So what is shift left, and is it actually your friend? So again, I'm going to say that it is. But before we get into why I'm saying it's your friend, let's talk a little bit about what shift left is. So you can say that shift left from a testing point of view is where we try to move the testing earlier in the life cycle, the left on the project timeline. So this goes way back to concepts that really were being popularized in the 1980s. This idea of test then code, using various forms of static testing and test design and so forth as ways of discovering defects before the code is even written, which of course is now back in the form of things like acceptance test driven development, behavior driven development, specification by example, those sort of things. Now, continuous integration, continuous delivery, or CI/CD, is where you're going to make sure that your testing is fully merged into the development, and it's being integrated continuously into some sort of framework, typically some kind of Jenkins, Hudson, or similar sort of arrangement with lots of automated tests that are part of that whole process, and that the code, once integrated, gets built and the tests get run, and then it gets delivered into a test environment for more thorough testing. Now, then you get to continuous deployment, which is where we're not only doing continuous delivery of software for further testing, but actually looking at putting that software into production at the time that it's done. Just sort of breaking out of the constraints of a 4-week or 3-week or 2-week iteration, and actually saying, no, as soon as we've got something built, we're going to be putting it into production. Of course, that means that we're making small incremental changes to the functionality as we go. The process for doing that deployment, including having testing fully built into what's often called the pipeline, is very important to try to avoid various kinds of nastiness that happens when insufficiently tested code gets pushed into production. Now, you'll also hear DevOps. So DevOps is just obviously taking the phrase development and operation and pushing them together. And this is a collaboration and communication thing primarily, though it gets mixed up with the CI/CD and continuous deployment stuff quite a bit. But ultimately, it's about making sure that you have smoother deployment of software into operations, because the operations people know what's coming, and they're not surprised by it, and then there's fewer things that go badly. If you ever spend any time working with operations people, you'll know that they sort of have a reflex reaction to changes being pushed into production, which is to just say, oh no, something horrible is going to happen, because a significantly large percentage of operations incidents are triggered by changes being made into systems. It's not just keyboards breaking and that sort of thing. Though that happens, but a lot of it is something gets pushed into production and it breaks something. So the idea of DevOps is that we try to drive that cost down. And the cost, of course, is not just on the operations side of support people having to run around and fix the problems. It's also lost productivity. Now, as you can imagine, since we're talking about pushing software through and testing pipelines and so forth, this is all moving too quickly for the bulk of the testing work to be done manually. So automation is a big part of this, and not just test automation, but also all kinds of automation of the various stages along the way when software is being developed all the way to where it's being pushed. So this has implications for you as a tester. And one of the main implications is that you see is a transition for testers to a heavier emphasis on what's sometimes called SDET. So SDET is a software development engineer in test. Sometimes you hear these people referred to as SETs, software engineer in test, or technical test analyst is another name that you would encounter. And regardless of what we call it, the SDET is a special kind of tester. So as I'm pointing out with a little GIF animation here, this is the Prague astronomical clock or astrological clock. I forget what the exact name is. And you know, when you approach testing from a purely behavioral black box point of view, you know, you would look at the clock and say, well, is the time correct? Are the little moving figures that are up there that you can see if you look at the top, are they moving correctly? Is the day correct, and so forth? In other words, behavior. But as an SDET, you would be expected to not only be able to evaluate whether the clock is telling correct time and date and so forth, but in fact how the clock works inside and why it works the way it works. So this is the same thing with software. An SDET takes a highly technical perspective on software, how it works, how it fails. They use tools. They build their own tools. They customize tools, so they have a strong ability to get in and actually code things or script things. They can read code, write code. So this has been going on for a while, this trend towards demanding a higher level of technical skill in testers. And so all we're really seeing here is just more of the same, this movement towards, you know, insisting that testers be more technical. So let's take a detailed look at what that's going to mean for you. So it's an obvious statement, and not necessarily very helpful to say you're going to be involved in test automation. The reason I say it's obvious, but doesn't tell you a whole lot, is because a lot of times when people think automation, they go, oh yeah, yay, automate through the GUI. I'm going to get Selenium or something like that and start going down the GUI path. But as I have argued for years, GUI-focused test automation really is a wrong turn. It was, I mean, I have no animus against testing, doing automated testing through the GUI when that's the right way to approach it, but it's got a lot of problems with it. And if there's any other way to automate rather than through the GUI, that's something that you really ought to try to exploit. A few weeks back, I was in Krakow in Poland giving some talks at the Nokia Test Dive conference there, which was a wonderful experience, by the way. Kudos to the Nokia folks for putting that on and having me come. One of the talks that I gave there was about non-GUI test automation, and I spent some time giving examples of why GUI-focused test automation is such a potential disaster. And I'd encourage you to go take a listen to that keynote. I posted it on our YouTube channel, which I'll put the coordinates of our YouTube channel up a little bit later, and you can go check it out if you want. But so rather than go through the litany of horrors that can be associated there, I'll just refer to that. It's associated with GUI test automation. I'll just refer to that presentation. But assuming that you agree that, yeah, you know, GUI test automation is fine in small doses, like, I don't know, very strong alcohol or something along those lines, what else should I do? Well, command line interfaces, CLIs, are great places to automate. Application programming interfaces are great places. Data layers are great places to automate. Network layers, network services layers, also great places to automate. So an SDET would know how to do automation through all those layers and would know how to recognize enablers and disablers for automation through any of those layers and pick the right mix. Now, it's not just what layer to automate through. There's also the levels that you are going to automate at, and you want to be able to effectively participate in automation of unit testing, working collaboratively with the developer, but also unit integration and system integration testing. And I'm going to come back to those because they're really important points that I think need to be stressed. And of course, also automating at the system level. System automation, system test automation needs to be part of the pipeline as well. Now, I am not going to repeat a mistake that I made closing in on 30 years ago in my career, where I was so singularly focused on test automation that I felt that pretty much all tests have to be automated. What I learned when I made that mistake was that there are a lot of things that need to be tested that really can't or shouldn't be automated. Excuse me. And so I am not by any means saying, hey, automate everything. But a lot of testing that is essentially verification. By verification, I mean checking that specifications have been met, can be done in an automated fashion. Now, validation, no. When you're trying to test for fitness for use, there's really limits on how much automation can be done there. So proper mix of automated and manual testing is important, and there will always be a place for manual testers. But automation is also important, but automation is not the only thing you do as an SDET. So developers are great. I love developers. I was a developer for a number of years before I became a tester. But developers have cognitive biases associated with what they do that makes it hard for them to spot certain bugs in their own work. And developers, of course, are not particularly interested in testing as a profession. Of course, it's because if they were, they would be testers, right? So the SDET has a role in unit testing of coaching developers to help them apply best practices with respect to white box testing and black box testing, and also the use of tools. So you should cultivate your skills in these areas and also cultivate your knowledge and understanding of code coverage. A lot of developers would not know what statement coverage, branch coverage really mean. They might have a basic idea, but some of the nuances they wouldn't necessarily know. But you should, and you should be able to explain them. You should also understand more sophisticated techniques like modified condition decision coverage, or MCDC, which is about not just testing the control flows, but also testing the logic that drives the control flows. Because in some cases, there's some pretty complex logic, some complex Boolean expressions that are being used to drive decision-making and looping and branching and so forth in the code. And you should be able to help people understand what those measures mean and when 100% coverage in those areas should be achieved. And also, of course, understand when it's not practical to insist on 100% coverage in those areas. For example, there can be branches in the code that have been inserted purely as a defensive programming kind of measure. So, that branch is like, okay, if you get here, something really weird has happened, so throw an exception. I don't know how I got here. Well, that can be kind of a difficult thing to force. Now, you may want to try to force it with a debugger just to make sure the exception handler works, but insisting that be part of the routine automated unit tests that are in the continuous integration framework is probably not smart. So you got to be pragmatic. Your objective here should be to help the developers do better unit testing, and also to help them avoid false confidence. Statements like what you'll find in one of Kent Beck's books on extreme programming, just to pick on Kent, no offense, but he made a comment in one of his books that with a fully automated set of unit tests, you can refactor anytime you want without having to worry about breaking your software. You don't have to worry about regression, which is, of course, a stunning statement, because it's basically saying that you can develop a set of unit tests that are 100% effective against regression bugs, which is impossible. So you can help people understand why that's impossible, why tests can show the presence of defects but cannot prove their absence. Now, this is about knowing tools for sure, but it's about knowing more than tools. There's this old saying about a fool with a tool is still a fool. And actually, my friend and colleague Joel Oliveira is pushing a spin on that. Is a fool with a tool is not a fool. A fool with a tool is a dangerous fool, because they can make mistakes and think that they can do things they actually can't. I posted something on LinkedIn recently where I was like saying, if you're involved in test automation, you really need to understand what the Sorcerer's Apprentice scene and the Fantasia movie means. It has a lot of meaning. So be a concept expert here, not just a promoter of tools. Okay, well, there's a blast from the past for you. It's a scene in one of the Matrix movies of our protagonist here stopping bullets with his hand, putting his hand up and making the bullets all stop and fall to the ground. Now, you can't do that, probably, but remember that what was going on in those Matrix movies is that by swallowing the red pill, the characters basically became aware of the internal operations of the Matrix and were able to see inside it and manipulate things. So I'm encouraging you to take the same kind of approach to testing of figure out how operating system options are important from an application behavior perspective. Look from the inside. Know what's going on the inside of the matrix here. Get hip to how dynamic analysis tools can help you watch things like memory, CPU, or disk usage, to look for memory leaks, those sort of things. So yeah, know what's going on inside, and SDET knows how to look inside. When we talk about white box, sometimes people think white box just means knowing what's going on in the code, but in fact it really needs to mean not just knowing what's going on inside the code, but what's going on in the system itself while your code is executing. Now, data. You may not be dealing with this right now, but it's a decent chance that you're going to have to deal with large and or complex data sets at some point in your career as an SDET. So you need to figure out how to be an effective data-oriented tester. Now, I'm not saying that data orientation is all you do, but I'm saying that data orientation needs to be part of your mindset when you're developing tests. So you need to know how to get into the data and crawl around in it. Run tests that manipulate data and be able to evaluate the results of those data manipulations for correctness. Now, in some cases, you'll be able to create full test oracles. Now, remember, a test oracle is the thing that tells you the expected result of the test, and a full test oracle is one that can evaluate all of the data. In some cases, you may have to settle for partial test oracles, quick and dirty kind of approaches that can look for things that shouldn't exist, like, for example, checking value ranges on integer values in tables. You could say, well, I don't know what all the right values are, but I definitely know that if there's a 0 or negative value in this particular field, or a value that's greater than 1,000 in this particular field, that's a problem. So I'm going to do queries to look at whether any such data exists. Automate via the data layer, either directly going actually into the database itself or indirectly through the application. Be able to read things like entity relationship diagrams and other kinds of metadata, database design documents to really understand what those mean. And not just from a functional point of view, but also a non-functional point of view. Reliability issues, security issues, performance issues, those are all things that you can find by perusing through metadata and database design information. Know how replicated and distributed databases work and know how to test those, and know how to force interesting things, or try to force interesting things, like, say, race conditions and data getting out of sync when it's stored in multiple locations. So there's a lot to know here. Don't assume that you can learn this quickly or easily. Certainly you can become aware of the basics in, say, an hour-long presentation, and I may at some point be convinced to give an hour-long presentation on data and data structures and data tools and so forth, but you can by no means master these things in that period of time. But as an SDET, you should plan to master these data concepts. Now, I sort of hinted at this before. Security is important. Security is highly technical, it's highly complex, and it's a huge, huge issue. Remember back to earlier this year, for those of you who are American citizens like me, we had this huge Equifax leak, and that happened because of some really boneheaded behavior on the part of the security folks there, where they relied on a single layer of security at the web server layer and then didn't update the web server with security patch. So when people got through the web server, it was just anchors away on all of the data. So you would need to know how to look at things like intrusion detection systems, intrusion protection systems, firewalls, and so forth to look for what's called defense in depth, multiple layers of security, using static analysis tools, using network sniffers to look for weak coding constructs, for example, for important data being sent in the clear across your networks. Learn enough about security to know not only code security, but also design issues, not just application security, but also network security. You need to be aware of both. We just started running a 3-day advanced security tester course, and it's been very well received so far. This is a great way to get started in getting more security aware and being able to participate in these kinds of activities and understand encryption and passwords and public key infrastructures and how they work, what authentication and authorization mean, and how to test those in the context of role-based security. These kinds of things are highly technical, but they're also extremely marketable skills, and you will be happy if you gain a level of expertise here and apply it in your work. Happy because it's fun and rewarding, and happy because it's a good career move. Now, people sometimes talk about, yay, we're doing integration testing because we're doing continuous integration. And I say, no, 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 no. Just because you put all the code in a common repository and rerun all the automated unit tests does not mean that you have done an integration test. The proper integration test is checking to make sure that everything, when it talks to other things, that those conversations go properly both directions. And this is getting to be a huge deal, even huger deal. I mean, if you think about how mobile works, you have this incredible amounts of interoperability that goes on there, and yet still integration testing is underperformed and not well understood. Now, if you need to explain integration testing and why it's so important to people, you can talk to them about the Mars Polar Orbiter, which I've included a little graphic here. The Mars Polar Orbiter mission, it got all the way out to Mars and then was lost. And the reason it was lost was in part due to improper integration testing. And when I say that, why was it due to improper integration testing? Well, there was a piece of software in Pasadena, California at the Jet Propulsion Laboratory that was communicating to the software that was on the Polar Orbiter. And the piece of software in the Jet Propulsion Laboratory was using imperial units, and the Polar Orbiter piece of software that was communicating to it was using metric units, which is bad when you're talking about things like how to get into an orbit, because feet and meters are off by a factor of 3. It's an interesting write-up in Wikipedia, and you can see the little figure that I've included here of what the planned trajectory was and what the actual trajectory ended up being. And as you can see, they were not right. So part of the problem with integration testing is it's an in-between place. It's in between two systems, it's in between two units, and those systems and units can be properly and adequately tested, and that still doesn't tell you enough about whether they work properly together. So who owns that place in between? Well, somebody needs to, and the SDET needs to be that champion, because they need to know enough about white box, black box, and other kinds of techniques that allow them to design proper interoperability and other kinds of integration tests. Now, integration points are direct sometimes, but they could also be indirect. So they can be API layers, they can be data layers, so you have to be sufficiently technical with both of those things, and this brings us back to data, to be able to identify those integration points. Figure out where those interfaces are, where data comes from, the data sources, where it goes to, the data sinks, be able to perform a thorough test coverage analysis to make sure that you're not missing anything. Now, service virtualization is a popular way of doing system integration testing to some extent, and it has its value, but there's definitely significant risk of false negatives with service virtualization. False negatives being situations where the tests appear to pass, but they're actually not working. So service virtualization is great and can help you start system integration testing earlier, which is always smart, and it's always shift left to start any level of testing earlier. But it's not smart and it's not shift left to assume that virtualization is the end-all be-all. Now, test design techniques are very important here, and I've been stressing test design techniques quite a bit, of trying to kind of outsmart the software as it were, and be clever about where you go looking for bugs. But sometimes bugs can be more clever than us, and they can be in really unpredictable places. And of course, hackers use chaos as well to try to defeat systems. So you need to be smart and know how to do random kinds of testing. Random can be your friend. So fault injection or fuzzing tools are really valuable. Know how to use these, know how to use them on configuration files, know how to use them on data files. Know how to create dumb monkeys and how to use dumb monkeys to do all sorts of fun testing like security tests and reliability tests. Randomness in data. Is it supposed to be random? Sometimes what's supposed to be random isn't actually random. So get hip to how to use randomness in your testing and in technical ways. Now, I'm not talking about randomness like just sitting there and banging away at whatever occurs to you, because you're not going to have enough time in the lifespan of the universe to make progress that way. But some cheap, smart tools can help you do it. I wrote an article which was recently republished in Luxoft's, I think it's called Logeek magazine, and we kind of bumped that up to the top again by reposting it in our newsletter last month, I think. It's on how to create dumb monkeys with free tools and use those. You might want to go take a look at the newsletter archive on our website if you want to give that a read. Excuse me. Know where to focus your efforts. As the principle of testing goes, exhaustive testing is impossible. You can't test everything, so you got to be smart and you got to be able to focus. Now, random types of tests allow you to scatter your testing over a lot of different areas, which is smart because, as I said, bugs can be unpredictable, but sometimes bugs are predictable. And so you can use things like cyclomatic complexity analysis. You got an example shown on the left-hand side of the screen there, which is, by the way, the complexity analysis for that chunk of code that you saw earlier, that C++ code. Excuse me. Complexity analysis can be helpful from a predictive point of view, but it's also good to do a retrospective analysis using defect and incident data to look for where your defect clusters are. Know those bug clusters. Develop hotspot analysis tools that help you figure out where things break and employ those. Now, if you're an old dinosaur like me, you may have watched this particular bit of tragedy play out live on TV. This is the Challenger going up and up and up and appearing to be doing just fine there for a while, and then it isn't, and 7 people died when that particular moment you just saw happened. Now, that's sad. When things go bad, people die, but what's really tragic is when things go bad and people die or people lose money or people get hurt or what have you, and then nobody learns the lessons. We got to get smarter as a profession if we're to become a true form of engineering and learning from our mistakes like other engineers do. So let's look at a couple of lessons that you can learn from NASA's program, excuse me, space shuttle program, from the 2 losses. You might think that these 2 Challenger and Columbia losses have nothing to do with me, but in fact they do have lessons that you as an SDET can and should take away. So one of the things that happened with Challenger, the thing that happened with Challenger that caused that explosion that you're watching on the screen, is that when the temperature got to a certain point, there were O-rings, and enormous rubber O-rings in the solid rocket boosters that would get brittle due to the cold temperature, because that's what happens with O-rings. If you get them cold enough, they get brittle. And when they get brittle and then they're subjected to enormous force, they fail. And when they fail on the solid rocket booster, what happens is a jet of fire comes shooting out of the solid rocket booster, which in this case, that jet of fire was directed onto the liquid hydrogen tank, which blew up the whole shebang there, as you can just see. Now, the thing is that the engineers knew that this was a potential problem. They had seen issues with the O-rings before associated with cold temperatures, and they gave a presentation to management, NASA and Morton Thiokol management, Morton Thiokol being the subcontractor that built the solid rocket boosters. And the presentation was not convincing because they didn't give the data in a very presenting way. And there's a great write-up on this, sad but great write-up on how this tragedy could have been avoided and wasn't, in a book. I believe it's the graphical display of quantitative information. And in that book, the author talks about the presentation that was given and the presentation that should have been given. So one of the things that you've got to be able to do as an SDET, and indeed a tester in general, is to be able to communicate effectively about risk, about what could go wrong. Because that was really the root of what happened here, is that there was an ineffective communication about the risks associated with launching at extremely cold temperatures due to the nature of the O-rings. Now, Columbia failed because ice sloughed off of the liquid hydrogen tanks, because as you can imagine, they're extremely cold and they gather ice on them, and that ice fell and hit the heat shields on the edges of the shuttle's wings. And the engineers knew that this was happening, and they knew that the particular strike that actually damaged the Columbia had happened, but they decided, well, nothing bad's happened on previous launches and nothing could be done anyway because the thing's already up there. So they didn't do anything, and they didn't even warn the crew. Now, of course, as you know, the Columbia basically burned up and disintegrated on reentry due to heat leaking through the damaged shields. So some lessons to learn here from this, again, tragic incident is, do not extrapolate risk probabilities from small samples. I mean, there were a total of about 100 launches, shuttle launches, and ice strikes had only occurred on some of them. Ice strikes on the heat shields had only occurred on some of them. And you can't say that, well, there's been 3 or 4 incidents and nothing bad has happened, because that's the same argument that you could make for Russian roulette, saying that the gun hasn't gone off yet. It's important to think about risks and test results from a user or customer perspective. What was that nothing can be done anyway thought that you can read in the Columbia post-mortem by NASA is really chilling when you read it, because you're thinking, God, if it were me up there, I would want to know. I wouldn't want to not know, but they didn't tell them. So remember, as a tester, one of the things that you need to do is put yourself into that user or customer perspective. Now, I've kind of poked fun at NASA here a few times in this presentation, and I want to give credit where credit is due. NASA's safety record is truly amazing. If you think about what they do, they put people, not just people, objects, but people and objects on top of huge, huge amounts of explosives and shoot them into the most hostile environment imaginable. And in the entire time that they have been doing this, they have only lost 17 people. They lost 7 people on the Columbia, they lost 7 people on the Challenger, and they lost 7 people in the Apollo 1 catastrophe. That is a remarkable record, and if you compare that against, and no offense to our Russian brothers and sisters, but if you compare that to the Russian program, it's an amazing safety record. Now, interestingly enough, they've never lost anyone from a software failure. All 3 incidents that I just cited, there were hardware failures. But given how software is becoming more and more prevalent, this is not something that's likely to persist. Now, from the Challenger sadness to something hilarious. At least I found it hilarious. The movie The Dawn of the Dead. This is where somebody's in an elevator and the elevator door opens and in come a bunch of zombies from the mall that are going to eat the person. Truly scary for the person about to be eaten. So if the developers are, think of you like testers, like a band of marauding zombies that are going to eat them, you're probably not doing this really properly. But sometimes that's out there. And you need to be helpful as a tester. You need to provide a valuable service. Now, sometimes people get up, and this happens on and off for years. Again, to pick on Kent Beck a little bit, he got up at a conference in 1999, if I remember properly, a Quality Week conference in San Francisco, and talked about his shiny new extreme programming concept and how that was going to, find all bugs through automated unit tests, like I said before, and render testers obsolete. And so testing was dead. Then, it makes a lot of controversy when people say that. It's just, not quite accurate. If you think of these things I've been talking about, what's an SDET? Well, the SDETs is what a tester was at the beginning. If you read Beiser's books, especially software testing techniques, if you read Meyer's book, Art of Software Testing, you'll realize, wow, these guys were SDETs before anyone called them SDETs, but I said they were. I'm an SDET. I got my start as an SDET. I'm doing automated testing of Unix systems through the API level. So now what's happening is that this idea is just, it's back, everything old is new again, as the saying goes. So in support of shifting left, what we need is more SDETs. So anytime someone says, testing is dead, just, laugh at them. You can't eat them like an undead zombie would, because that's just rude and illegal. And it's not nice to do those kinds of things because they're just wrong. And, don't be mean to the people who are wrong. Just help them understand how SDETs are valuable. So all of these things I've been talking about, as I said, are really just best practices that have been around for a long time. I mean, I don't think there's anything that I've been talking about here that doesn't have roots that go back 20, 30 years or more. Of course, implementation is different. I mean, we didn't have Jenkins, Hudson, Docker, those kinds of things back 20, 30 years ago. But a lot of concepts of continuous integration, continuous delivery were things that were being done 20 or 30 years ago. In the early 1990s, I worked on a system that was basically implemented completely differently, but it was basically a CI/CD system. Now, in that case, continuous was overnight, but given the technology we were working with, that's what you could do. So don't be afraid of shift left and its various friends. Make them your friends, but you need to become an SDET to do that, because this is going to be very, very technical stuff. Now, ISTQB and ASTQB are working on some technical syllabi that are going to help with this. So there's going to be guidance as to how to become more technical, the skills you need to learn, but you need to not only learn the skills, you need to apply them to truly thrive in the shift left world that's coming. You need to be able to do these things and do them well. Now you might say, oh, I've been a black box tester for years. I want to stay a black box tester. So far, so good. I'm saying that's not going to work out real well. What I'm seeing working with clients around the world is an inexorable shift towards more and more technical skills being required of testers. So if you don't get technical, you may have an experience like when Ren McNary, my colleague, would run around with his shift left 2x4, slap his palm with it and say, shift left, shift left. You do not want to get hit upside the head by Ren McNary's 2x4, so shift left. Okay, so as usual, we're going to put the advertisement up here and also the coordinates for YouTube and all that good stuff, LinkedIn. Excuse me, while we do the Q&A. So I'll take questions for the audience here. Before I do, just a brief mention. Remember, We are happy to provide expert services, consulting, and training related to software testing. So please do make us your preferred vendor for any such services you might need. Let's see, we'll start with Lena Bowen. Good to see you back, Lena. Should you automate report testing by executing the storage procedures? I love that. I love that, Lena. One of the first automated systems I built, well, first, but I mean, it was one that I built early in my career in the 1990s. We did exactly that. It was all kinds of different reports and queries that were automated, and you submit through the command line interface these predefined queries and then compare against the results that were supposed to come out. It was super, super reliable, really fast. We had thousands and thousands of automated tests that we could run in the space of a couple hours and evaluate the results. It was just, yeah, it's a great approach. That's one of the things I talk about in that keynote from the Krakow event, the one about non-GUI test automation, if you want to go give that a listen. It's a really great idea. So my buddy Alex here, Alex, good to see you online, says, so do you believe that SDETs are replacing sets or they continue to coexist in the future? I would say that the distinctions there between software development engineer and test and the software engineer and test, there's really no uniform, consistently different meaning to what those are. So I hear some people talk about SDETs, and some people talk about sets, and some people talk about technical test analysts. And in their context, there may be differences between what they mean by that. But I think just in general, it's, you know, get more technical in the ways that I described. I wouldn't, well, as a consultant having to do business with a lot of different companies, I learned to kind of generalize, and it's true that there can be a risk that you generalize away important distinctions. So I wouldn't suggest that there's not an important distinction here in any situation, but I'm saying that in general, it's just part of that same bigger trend, Alex, of, you know, get more technical. Lance says, regarding the book that I cited, was that book The Visual Display of Quantitative Information by Edward Tufte? It was, indeed. I'm pretty sure that was the one where he talks about the Challenger. There was like a trio of books that came out within short order, one after the other, and it was in one of those three that were written all about the same time. But The Visual Display of Quantitative Information is the classic. If you have not read it, you really owe it to yourself to do it. It is mind-opening. It will change the way you think about graphs and charts and metrics forever. It's amazing stuff. Tufte can be a little bit eccentric, I guess. He's got a lot of great ideas. He also has this animus towards PowerPoint that, I mean, I have an animus towards PowerPoint that's purely practical in that it screws up a lot and it can be very clunky, but he's got an animus towards PowerPoint that isn't based on practicality so much as he just thinks it's just dead wrong to present information that way, which you can read up about. But you know, I'm kind of like, well, you know, it's a lingua franca and everybody uses it, so I use it, you know. But he's got a lot of great thoughts. The guy is clearly a genius. And if you have like $1 million, you can buy a piece of steel that he'll make for you. And it's just that. It's a piece of steel. You can find it on his website. Bill says, an HR person said that SDETs are obsolete. I think he is wrong. How do we politely correct that misunderstanding? Well, one of the things, Bill, that I would get into with this person is what when they hear the phrase SDET, what do they think and why do they think it's obsolete? This may be one of these nuances of definition where if you just call what I've been talking about by a different name, that you sidestep the whole conflict over that, right? So I'm not a big believer in getting too hung up on what you call things unless there's practical implications to that. I mean, I'll get into terminological debates with people over certain things, but this SDET versus SET versus technical test analyst, what an organization wants to call those, I think is fine, as long as it's the end result is the same. The testers are doing the kinds of things that I talked about. Donald asks, is there a place for analytical test methods such as decision trees, test state transitions? I think you're talking, Donald, about like the classic black box test design techniques, and absolutely, those are just as valuable as always. You're dealing with complex interactions of conditions. Decision tables can be very, very useful in modeling that. Doesn't have to be done with MCDC. If MCDC is something that people go, oh, that's just for airplanes, you can do the same kind of analysis with a decision table. Similarly, state transition diagrams are incredibly useful for understanding certain kinds of behaviors. So yes, but I'm maybe emphasizing white box kinds of things here, but the black box, the classic black box techniques are still, really valuable, really important things that I think all testers should know and master. And, we shouldn't get hung up on this. Are you a white box tester or a black box tester? I think you just have to say, yes, I am a white box tester. I'm a black box tester. I'm an experience-based tester. I'm a dynamic analysis tester. I'm a checklist and defect-based tester, and I employ every tool at my disposal to hammer on the software. I'm sure many of you out there have heard me cite the famous software engineering guru, Deng Xiaoping, who said that it matters not whether the cat is white or black, it matters that it catches mice. And of course, if you know your history, you know Deng Xiaoping was not a software guru. He was a transformative figure in recent Chinese history. But whether he was talking about the importance of abandoning dogma with respect to capitalism versus communism, I would just transfer that right over and say it's important to abandon dogma with respect to test design techniques. Know them all, use them all. Sridhar says, what's your take on the role of AI going to be in the testing world? This is a fascinating question, and this is just great stuff. AI is going to be really transformative. I'm not sure exactly how, but it's going to do a whole lot of things for us. For one thing, it's going to make testing crazy hard, because you will almost never have full oracles when you're testing an AI system, just because anything that could predict how it's supposed to behave would have to be just the same capability of that thing. But AIs will also be very useful as test oracles and as ways of automating tests. There's some very interesting work being done by some of our clients in the gaming space on the use of AIs for testing. It's just fascinating. So something else to look at and learn about for sure. I think the horizon on this is a little further away than the things I've been talking about, but definitely lots happening there, and this is a good place to start looking into. Tracy says, is this shift due to the Agile methodology blurring the lines between QA and developer? Why? Why is this change happening? Well, certainly, yes, Agile has had a lot to do with it. A lot of the impetus for testers need to be able to automate did indeed come out of Agile. And you could say that there's kind of a problem with that, because if you look at the early writings on Agile, the Kent Becks and the Ken Schwabers and Martin Fowlers and so forth, these are people who I don't want to be unpleasant towards them, but I mean, I just think that they didn't know a whole lot about professional testing. Maybe they'd never seen it done properly by an actual professional tester. So there was a certain amount of disregard for that. And then there's a big hole that was there for a number of years until you get Crispin and Gregory's book on Agile testing, which started to address that. And now we're starting to see books about how professional testers fill a vital role within Agile. But But yes, there's certainly left a lot of residue of, testing as a purely, automating unit test kind of perspective, which was the beginnings of that. Now, there's an old saying that there's no end to what can be accomplished if you don't care who gets the credit. And I think that applies here, that if we don't worry too much about why this is happening and get too hung up on some of the history, and some of it is indeed unfortunate and did cause some damage to testing as a profession and people's careers as testing, and cost some people their jobs and caused them a lot of distress in the early 2000s and continuing. But if we get beyond that and say, well, look, we are where we are. What's the right thing to do as a tester right now from a career point of view? I think you just embrace it. Embrace this. It's going to be fun. Really, trust me. As a person who's spent their whole life as an SDET, I love this kind of stuff. This technical crawling around inside the systems. So I really encourage you to learn to love it. Another question from Donald here. He says, I've been put into automation and testing in developers' default code for the idea of continuous integration, and we end up spending most of our time catching little more than incomplete code in progress, simple mistakes that they corrected without our input and other churn, all working without requirements. I hope this isn't continuous integration. Well, now that definitely sounds like there's some significant dysfunction there, which needs to be identified and resolved. Because that's not that's not a properly working system. I talked about that a bit in my keynote in Krakow, about that being kind of one of the things that can happen with automation, is it just gives you information that's not terribly useful. So it does sound like there's some dysfunction there, Donald. I'd encourage you to do some research into what's going on with that. Excuse me. One of the things that I saw happen not too long ago was it was a large, complex automation system built, and then it was used to develop thousands of tests. And the tests could be cleanly divided into two groups, basically. There was one group of tests that was very, very useful, found bugs, and sometimes, and when it found bugs, those were real, honest-to-God bugs. Most of the time it was doing what automated regression tests should do, which is build confidence. The other set of tests that were built with the same tool were really flaky, lots of false positives, lots of false negatives, not very useful, very difficult to maintain, and ultimately kind of got abandoned. But there's a whole lot of wailing and gnashing of teeth associated with the attempt to get that off the ground. This is a common symptom of what happens when automation is done without a proper test automation strategy in place first. So, Donald, I can't diagnose your problem from a distance like this. I'd have to come in and work with you guys, but it's what you're describing there does sound symptomatic of automation for automation's sake, the solution in search of a problem, no proper test automation strategy in place before the automation work is done. Okay, some of you may have noticed I'm trying to keep our webinars a little more lightweight, so I'm trying to keep them within an hour, and of course the one key idea webinars, which will be next week, are half hour, so I'm going to close this session out. We'll be done in an hour. So a little bit more about the resources available through RBCS. There's these free webinars that happen once a month, so check our website, rbcs-us.com, to sign up. If you want a special webinar presentation for your company only of this webinar or any other topic related to software testing, please send an email, info@rbcs-us.com, or contact us via our website. If you don't already receive our regular free newsletter, sign up at rbcs-us.com. This will get you valuable discounts on consulting and training services, along with that regular newsletter that includes a featured article like the one I mentioned on software testing and quality, and also news about what RBCS and its partners are doing lately. You can follow us on Twitter, Facebook, LinkedIn, and the coordinates that are shown here. Send me a LinkedIn connection request, and I will accept it. I promise. If you're a regular on these, you're good people. Do remember to check your email over the next couple days, because you could be the lucky winner of a free e-learning course from RBCS. You were registered simply by attending this free event. Do check out our digital library with recordings of these webinars, podcasts, and videos. If there's anybody that missed this webinar that you think would benefit from it, we will have this up, posted in the digital library and on the RBCS YouTube channel within the next couple days. We offer these free resources as a service to the software testing community because at RBCS we are a not just for profit company, but don't forget we do need to keep the lights on, so please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. Thanks for joining us today, and for my fellow U.S. citizens, have a wonderful Thanksgiving holiday.